A logarithm is the inverse of an exponential function. So that means a logarithm will basically cancel out an exponent. Logarithms were developed in the 1600s to help people deal with very large numbers, and they're still used today in certain scales and measurements, especially in science or economics, where you might have a whole bunch of variability in X. The Richter scale, for example, for earthquakes, you might have heard that the 5.0 earthquake we had recently in Western North Carolina is 10 times stronger than a 4.0 earthquake. Anytime you have a scale that kind of works like that, that is often a logarithmic scale where a small difference in the number means it's a whole bunch more powerful or a whole bunch larger event. When you change between log and exponential form, the key thing to do is to identify the base. The base, remember, is the number down below a logarithm or the number down below an exponent. The base stays in the same place and the other two numbers switch places. So the a and the x basically switch places in relation to the base. If you can identify the base and switch them that way, that will help you. Also, since logarithms and exponentials are inverses, they do cancel out. So if you have a log 2 with a 2, that cancels out and just leaves you with an x. Or even if it's written the other way with a 2 and a log 2 in the exponent, that cancels out and just leaves you with an x. We'll practice some of these together. I know this is different looking, but if you can identify the base, you'll find out that they are not too terribly hard to do. So let's go ahead and rewrite this first one. This first one, identify my base of 2. So that's the first thing I write down. Then the other two numbers switch places, which is a 3 there and an 8 there. And these with a number in them, you can kind of check and say, is 2 to the third power really equal to 8? And it is, so you know you are correct. I'm going to go ahead and skip over and do the next one. The third one. The base is 2, so keep the 2 put and switch places on the other numbers. So 2 to the negative 1 should be equal to 1/2. And you might recall that a negative exponent means that that number, that 2, needs to be moved to the bottom. So 2 to the negative 1 really is equal to 1/2. That's a way to check my answer if I have numbers. Working the other way, going from exponential to logarithmic form, I still identify the base, and I go ahead and just write the word log and put the base of 4 down as the little number beside the log. And then the other two numbers switch places. So the 3 and the 64 switch places. So I have log base 4 of 64 should be equal to 3. And it's true that a logarithm always equals the exponent. So when you're going in this direction, the exponent should always be on the right side of the equals by itself. Skipping over one, we'll do this one here. My base is 3. So just write it as a log with a little base down, the 3 down below it, and then the other numbers switch places. So log base 3 of 1/2 equals negative 2. And that should help you. Actually, I just noticed I had an error on that worksheet I'll fix in a second. That should be a 9 there. That is a typo on my part because 3 to the negative 2 is 1/9, not 1/2. I'll give you a chance to go ahead and try the rest of these. You might want to pause your video and then we'll go over them real quick. Okay, the ones you tried on your own should have been a 4 squared is 16. That one should be a 3 squared is x, and you could simplify that to say that x equals 9. You just solved a very simple equation there. On this one, it's a log base 2 of 32 equals 5. And by the way, a log always has to have this number right here, an argument that always has to occur. And then down at the bottom, you should have had a log base 5 of 3 equals x. Now this brings up a good point, log base 5 of 3. I could evaluate that using Desmos. Let's go ahead and pull up Desmos and try that. So to evaluate that, in Desmos, there is an actual function down at the bottom that I need to pull up. So over in my corner with my function button, you show the keypad, go to functions, and then under miscellaneous, you're going to be looking for the one that says a log, and you want to use the log a because that lets you do a base. So you just type in the base you had there, I think 3 of 5, and that gives you the